There it goes. Okay, it says it's live now. Hopefully this works out. I guess we'll start saying by saying a prayer. I can go ahead and say that. Our dear Heavenly Father, we're thankful for this day and thankful that we can be students at BYU Idaho, and we pray that we'll be able to have Thy Spirit with us to help guide us. That we'll be able to learn the material, and that we'll be able to complete our homework. And we ask that we'll be able to have Thy Spirit and say these things in the name of Jesus Christ. Amen. So again, I don't really have anything specific, I just, other than to talk about any of the problems, that we need to talk about. But you said, you're just kind of trying to, just since now we're actually recording it, you were saying that you're trying to get down the trig formulas and trying to remember those, and I need to really start just trying to memorize them one way or another. Mostly the identities are what I have trouble remembering. I'm actually the other ones too. I need to know how to, the derivations of each of them too. But I know how to figure those out if I need to. I can derive them probably fairly quickly, but if it comes down to it.
One thing that we talked about in my pre-calc class last semester is so if you have now I'm getting them all jumbled in my brain. The sine squared plus cosine squared equals 1. If you want, let's say, the tangent squared formula, you just divide everything by sine and you'll get a cosine out. And you move it over algebraically. And that's the one thing that helped me out the most, because with just knowing that, you have the original formula and you can derive the two others. Well,
yeah,
two others from that.
Okay.
Algebra.
I'll have to do that. I'll have to try that out. And we're surviving all those story problems.
Yeah, it's just, especially with the area one, it's taking me back so far in math. I haven't done problems with areas of a rectangle in so long.
Yeah.
It's fun.
Yeah, I don't mind. I don't mind that. The only thing is just when I go through and I spend so much time on a problem and then I mess it up one little thing and throws off the whole problem. But that homework before the trig, seriously, that I think I was up all night just about one night trying to do that.
Yeah.
I don't know. Maybe I'm just slow at it. I get it. I understand it, and I can figure it out. But I'm just not as fast at it.
That's fine, as long as you get it. There are people who do things fast and they just don't get it. So.
Yeah. Well, I don't know if there's anything to review with the quiz. I'm working on.
Sometimes on iLearn it tells us what to talk about. I don't think it does today.
What's that?
Sometimes on iLearn it tells you things you can talk about in your group.
Yeah, well, maybe I should do that. Well, just what I've seen just says, talks about some of the activities. You can go through some of the activities if you want.
Yeah. Which one?
Let's see. I think you can kind of just choose whichever one.
Did you want to do B because it had problems on it? A was just the reading and definitions.
Let me see. Which one are you?
Or do you want to do one from day 5? Because I haven't done those.
I haven't done any. Well, no, I've started on day 5. Do you have a problem with? Yeah, I'm just started on day 5 actually. Do you have a problem sometimes with it has those prep assignments at the end, and the prep assignment where it says prep for basically for the next day.
Oh yeah.
And you look at it and it's like, okay, I'm supposed to be prepping for this and doing these problems, but I've never seen this before. It's kind of
like, I don't know. I like when the prep assignments are the definition ones. Because then it's like, okay, I'm reading the book and I'm understanding. But then, like, today wasn't too bad. But there are some days where it's like just jumping straight into the math. And like, and I sit there for like hours just on that.
Yeah, it's funny sometimes because it's like, okay, I'm supposed to be doing these problems, but we're not going to learn how to do them actually till tomorrow. There was one I just totally botched it up. I think I got almost every answer on it wrong, because it did. I think we just jumped straight into math on it, and I had no idea how to do it. And I spent all this time, and finally I just like, I don't care. And I went through that's as good as I'm gonna do. And I went through the problems the next day and learned how to do it. I was like, oh, good. And I went back and actually redid it after that.
Yeah.
And it wasn't too bad.
There are some, and I am like almost positive that my answer is correct. But I think the way I type them in is different than like the answer, because I tend to use a lot of parentheses when I type it in. And it's like, I go in and I type it in a couple different ways and it's still not right, and I take it to the tutor and they say it's right, but it doesn't come up right. That's what I find frustrating.
Yeah, I have that problem sometimes too. And the instructor will usually mark them right, unless. Yeah. But it's these. I get into this thing sometimes where I got it wrong, and I look at it and like, okay, I'm sure that's right, and then I go through it and then realize, so I send it to the instructor and say, I'm sure this is right, and she comes back and says, and tells me, no, it's supposed to be this, and it's like, oh yeah, that's. But a lot of times she's marked right. Okay, well, we could. Do you have the worksheets printed out?
I have them pulled up right here. I usually. Hold on, I'll look up. Which one were you thinking?
I don't really like the first one. Are you looking at the one that says trig derivative apps at the start?
Yeah.
At the top? I don't really like number 1 because I got the same answer that they did in the key. I actually tried to divide it out. I tried to, figure out what am I trying to say? So I tried to actually enter it into the calculator, and I'm getting a completely different answer than they did. So I don't know what's going on.
Okay.
But 2, I got 2 pretty good, so we could work on 2. Does that sound okay?
Yeah.
There's one thing I got wrong on 2 that when I looked at the it didn't make sense at first. But anyways, when I looked at the key, I realized what I'd done wrong. So, and I don't really have any way to put something up on the screen that I know of, other than to show it. But it says an airplane flies at an altitude of 5 miles toward a point directly over an observer. Speed of the plane is 600 miles per hour. Find the rate at which the angle of elevation is changing when the angle is pi over 6 and pi over 3. So when theta equals pi over 6 and theta equals pi over 3. So we have to do 2 answers.
Wait, so it's 5 miles? Like, so if it's a right triangle, 5 miles would be the hypotenuse?
This is the picture right here.
Oh, mine doesn't have a picture.
Let's
Oh,
see.
did you draw it out?
So you have,
Or are you looking, are you looking on the answer page? Is that one?
no, I actually did this one pretty good. No, I'm just redrawing it here. Okay, that was, I made way too big there. This one I actually got perfect. It was awesome, except for one problem I made, and I'm surprised I got it. They did that, but I'll show it. That was right at the start. Okay, so we have a. Oh wait, that's not. Three. I want the airplane. Okay, so we have the plane is 5 miles in altitude. And it's 50. It's going 600 miles an hour. Okay, and that's okay. So saying this is a fun rate. Yeah, and we don't know what the okay. So, anyways, so there's my picture of it that I have right there. Focus on it. Okay, can you see it?
Yeah, that looks like mine.
Oh, hey, look at that. And so it's flying towards you. And the thing that I got wrong that I should have thought about, it's just hard. You know, I don't know. It's just basically the velocity I had wrong. I put the velocity as being 600 miles per hour, which is not true.
It's not.
Because it's coming towards you. So the velocity is actually negative 600 miles per hour.
Oh, okay.
And that was, and I went through the whole thing, and that was the only thing I got wrong. Once I changed that, it was perfect. So, but so we're trying to figure out the find the rate at which the angle of elevation theta is changing. So we want basically the change in theta per change in time, right?
Yeah.
So basically, we're looking for that right there, d theta over dt, and let's see, and we know that our out. Yeah, if we got the 5 miles, I have that all labeled. What's the other thing that we have? We know that in that bottom part that's on the ground, the other part of our triangle on the ground, and it's parallel with the. Basically, that's our speed, our velocity. So we have our change in. I labeled that as x, by the way.
Yeah.
Which was kind of cool because that was the same way the key labeled it too. But so we know that the change in x per change in time equals negative 600 miles per hour. Let's see. Then we have what I did this different than they did at this point, and I have to say my way was better than what they did. But my way ended up a lot simpler, I think. Because I looked at what our variable was. Our variable is the is the adjacent side of the triangle, right?
Yeah.
And so to me, I figure, okay, I want to put that on top. And we have basically x over 5, which is a cotangent formula. So if we say the let's see, the cotangent of theta equals x divided by 5. You see that?
Yeah.
Does that make sense? Okay, so then we just need to find the derivative of that. And using the handy cheat sheet, which I already have this written down, so I don't need to look up. But basically, we know that the derivative of theta, or excuse me, the derivative of the cotangent is negative cosecant of theta, or squared of theta.
So that's
Yeah, negative cosecant squared of theta. And since with respect to time, we have to use the chain rule, and we have to put basically that this is negative cosecant squared of theta times the change in basically d0 over dt, right?
yeah, these days. Wait.
And that equals, we have, and on the other side of the equation, we have x over 5. So I just kind of took that x over 5 out of it and put that as 1 over 5. And then we have the derivative, basically the derivative would be 1 over 5 at, well, x, which is, that's just 1. So it's basically just 1 over 5 times x, right? All right. Let me rephrase that. 1 over 5 times 1.
Yeah.
Right? But again, this is with respect to time. So we end up with dx over dt.
Yeah.
So this right here. Negative cosecant squared of, it's weird when the screen switches. It throws me off. Negative cosecant squared of theta times, yeah, time equals 1/5 in changing time. So then we just need to at that point, well, we can plug in our values. We know change in x per change in time is negative 600 miles per hour, right?
Mm-hmm.
Yes.
So we multiply that in.
Yeah, we can multiply that by negative, or by 1 over 5.
Okay.
So basically negative 600 divided by 5. Equals negative 600 miles per hour. And that's and we also, and on the other side, to isolate that change in theta over change in time, which is what we're actually looking for, we'll end up just dividing by the cosecant squared of those two. We're looking for both, theta, which were two different values, pi over 6 and pi over 3, right?
Yeah.
It'd probably be easier just to figure that out first. I don't know. I'll go ahead and move it over this time. Change in theta over change in time equals negative 600. Oh, but since it's negative cosecant, the negatives cancel out. Right?
Yes.
So actually, what was 600?
I forgot to carry my negatives when I divided by 5.
Calculator here. I should be able to figure negative 600 divided by 5 without using a calculator, probably. But
120.
so we have negative 120 but the negatives cancel when we divide by cosecant squared of theta. So yeah, we basically have this right here. Oh, where is it? There it is. That right there. Is that what you have?
Almost. I just didn't divide it over. Yeah.
Okay. I didn't do that the first time either. I just went ahead and did it this time.
Yep.
All right. So now we just need to plug in pi over 6 for the first one.
I need a real calculator.
Actually, the other thing we can do too, which might make more sense, especially since I don't have a cosecant button.
Flip if you flip it.
Yeah, we might as well flip it. That would make more sense, huh? So it's actually 120 times the times. Let me see. Cosecant would be sine.
It's fine. Okay.
20 times.
I have to figure out if I'm in degrees.
All right. Yeah. Oh, yeah. That's true too. I think I switched mine back to degrees, so I need to make sure to put mine on radians too. Okay. Because some of these, there was another problem here that was in degrees, I think. Anyways.
Man, I haven't used this thing in so long. I think it's smarter than me. Here's my pi button.
Yeah, that's right. Oh.
There we go. Did you get it? I got 0.004.
004. You went, let me see, sine. Oh, I think you forgot. Let me see. Oh, you're still showing it. It's just not showing on my screen. Come on, flip back around. Oh, it's because I'm talking.
Do I need to say something?
Yeah, there you go. Did you square it? Remember, it's sine squared of theta.
Oh, true.
That's what I think. That's what I was trying to see.
Yeah. I wrote it down that way, I swear. I just couldn't type it that way. Now I got 0.002. Yes?
Oh no, it's times it because we did, since we did sine. Remember, we did it's the inverse. So it was divided by the cosecant. Remember?
No. Wait, what? Sorry.
Because we had, let's see, because we had 120
Yeah, that's what I
divided by the cosecant squared of theta, right?
That one.
And then yeah, we changed it just to sine squared of theta and brought it up, so it should be 120 times the sine squared of theta.
Oh, I just flipped it. I don't know why I did that. That makes sense. There we go. It's a real number now. 30.
Yay! Okay, so now we just have to do the same thing for pi over 3. I'm surprised Corbin isn't here. He's usually really good. But I know things happen.
90.
Let's see. Did you get it already?
Yeah, I got 90.
Yay, that's what I got too. And those are the answers actually. So, of course, although I have to tell you, it doesn't come out that way if you don't if you don't use negative 600.
Yeah.
Yeah, but yeah, that problem I didn't think was too bad. The way that I did it actually is different than what you'll see in the key. You get the exact same answer because they did instead when they did their first formula, instead of doing the cotangent of theta equals x over 5, they actually did the tangent of theta equals 5 over x.
Mm-hmm.
And it made the problem like way more complex. So, I don't know.
I think that would be, but I feel like that'd be my first thought too, because it's like, oh, opposite over rotation is tangent, just because it's like the first thing I think of.
My thing is, if I can keep the variable from ending up on the bottom ending up in the denominator, then that's what I like to do.
Mm-hmm.
And I think that tends to simplify things a lot of times. But anyways, that was one of the problems. Was that fun?
Yeah.
now, now you just got 6 to go on that one.
Yep.
I still have 2 to go. I'm still trying to get my head wrapped around 6 right now. There's something just not clicking with it. I don't know. But yeah, it's 6 is odd to me.
A light source.
Yeah.
Oh, it's a circle problem.
Well, sort of. I don't think it's.
Oh, not. Oh, it's like
It's still just a triangle the way because it just has an angle of it has a slant height.
Mm-hmm.
And then you're trying to figure out basically the distance down directly.
Mm-hmm.
So you're trying to figure out the height, and you do know that the diameter of the table is 4 feet, so the radius would be 2 feet. So with that, I got a triangle build up. But the thing I keep picturing is, okay, you have this table that's a fixed height. You're trying to figure out at what height will the illumination be the maximum. And the thing that's, I guess, thing I'm getting stuck on is it seems like there's like a specific height where it would be whether the light's either completely on the table or it starts falling off the sides.
Yeah.
So I don't know. I guess
But so
maybe not though.
I think when you add in the radius, it accounts for when it like falls off the table because you're putting the 2 feet into the equation. But that one confuses me because you only get the radius, well, the diameter, but you don't get an angle or the height. So
Yeah.
are you just solving it algebraically?
Well, it's wanting a maximum. So I'm gonna have to do a derivative
Mm-hmm.
and then set it equal to 0. Guess I should just give it a constant. I don't know what the constant is, but I don't know. I'll have to
Ooh,
play around with it.
I see I'm kind of cheating. I'm looking at the cheat sheet,
Yeah.
but it's telling you that, so it makes sense. The height is 2 times the tangent of alpha, which makes complete sense because tangent is alpha.
Tangent
Yeah, yeah.
would be the tangent would be the tangent of alpha would be 2 over x. So, or 2 over the height.
Mm-hmm.
Yeah, so, and you said it's, yeah, I see.
So
So,
then, yeah, it's 2 tangent alpha is the height. And then with that, you can algebraically solve for alpha, I think is what you want.
oh, okay. I don't know what that constant is.
It looks like it's all kinds of complicated.
Well, I think I'm gonna play with that, but I think I want to get my quiz done first.
Yeah, I need to do that too.
And I still got homework for another class.
I just barely finished my physics homework before this. So.
Oh yeah, I have mine's just the 2 other class. I'm taking a 2-credit class. I have a hard time getting to that one because it's like I'm living and breathing calculus lately. I don't have much time for anything else.
I wish like calculus was my only hard class this semester, but I'm also taking chem and physics, and so
Oh man,
I'm drowning in all of my classes all at the same time.
that is so hard.
Yeah.
Oh gosh. Yeah, and they're probably both classes that use calculus, aren't they though?
Yeah. So like sometimes they overlap. Like right now in physics we're talking about derivatives. Like the derivative of velocity is position, or position is velocity. But yeah, it's fun.
Fun. Do you work though, or are you?
I would have liked to work this semester, but I can't. I'm
Yeah.
drowning.
Well, that's what I think. When I'm going full time, I don't think I'm gonna be able to. At least I'm definitely not gonna be able to work full time. And I'm working full time right now.
hmm
So that's why I'm sticking to just 6 credits, and it seems like enough.
Yeah, it's smart sometimes.
Anyways, thank you.
Yeah.
I think I'll get off so we can get on our quiz.
Okay,
Good luck
cool.
on it.
Huh?
Good luck on your quiz.
You too. Say a prayer.
Yeah, I don't always think to do that when I'm getting ready to study, but it does seem to make a difference. So, all right. Well, thank you very much. I'll send you the link here shortly. All right.
Okay, thank you.
Bye.
Bye.